Hey everyone, welcome. Let's start with a bit of a riddle. How can you break something apart, distribute it, and somehow end up with more? We distribute yet things multiply. Might sound a little strange, but it's actually the key to unlocking one of the most powerful tools in all of math. Let's dive in and see how it works.
You know that feeling when you're staring at a multiplication problem and just wishing you could snap it into smaller, easier pieces? Well, guess what? You totally can. And learning how is kind of like getting a mental math superpower. So here's what we've got lined up. We're going to start with a fun little multiplication puzzle. Then we'll introduce the secret property that just cracks it wide open. From there, we'll see how it turbocharges algebra, learn some really powerful shortcuts, and yeah, by the end of this, you'll have a new math superpower. All right, first up, the multiplication puzzle. To really get our heads around the big idea here, we're going to start with one specific problem that looks deceptively simple on the surface. Okay, so here's our test case, 23 times 27. Now, yeah, you could punch this into a calculator or do the long multiplication, but hey, where's the fun in that? We're not here for the quick answer, we're on the hunt for a more elegant pattern. So let's play with this a little. What happens if we just nudge one of these numbers up by 1? So instead of 23 times 27, we do 23 times 28. How much bigger is the answer? The solution to that little question, well, it actually uncovers a fundamental rule of mathematics. And that fundamental rule, that secret tool we've been hinting at, it's called the distributive property. Seriously, this thing is the key that unlocks not just our little puzzle, but a huge part of algebraic thinking. And the best part is just how simple this property really is. All it says is that multiplying a number by a sum is the exact same thing as multiplying it by each piece of the sum first, and then adding those results together. That a on the outside, it just kind of shares itself or distributes itself to both the b and the c inside. So let's circle back to our puzzle. We can think of 28 as just 27 plus 1. Now let's distribute that 23. We get 23 times 27 plus 23 times 1. See what we did there? The original product was just 23 times 27, so the new product has simply gotten bigger by 23. We didn't even need to do any heavy multiplication to figure that out. So, that was cool for 23 and 27, right? But the real magic, the place where this goes from a neat trick to a powerhouse tool, is when we bring in algebra. It lets us prove that this pattern works for literally any numbers you can imagine. Okay, now let's level up. What if we bump both numbers up by 1? So we have a plus 1 times b plus 1. When you expand that out, check this out. You get the original product, ab plus a plus b plus 1. The increase is always the sum of your original numbers plus 1. It's this perfect, totally predictable pattern every single time. You know, these patterns that are always true, no matter what numbers you plug in, they've got a special name in math. They're called identities. It's not like a normal equation you solve for one specific answer. An identity is a statement of truth that just works for everything. The distributive property itself is a classic identity. All right, let's keep going because this is where it gets really fun. Knowing a few of these key identities is kind of like having special moves in a video game. There are these awesome shortcuts that let you slice through certain problems with incredible speed. First up, we have the square of a sum. Now, when you square something like a plus b, a lot of people think you just square the a and square the b. Nope. You get a squared, you get b squared, and you get this super important middle piece, 2 times a times b. Okay, but how is this actually useful? Well, let's try to calculate 65 squared in our heads. We can think of it as 60 plus 5 squared. So, using our new shortcut, that's 60 squared, easy, 3,600, plus 5 squared, super easy, 25, plus that middle term, 2 times 60 times 5, which is 600. Add it all up, 3,600 plus 600 plus 25 gives you 4,225. So much easier, right? Our next shortcut is going to look super familiar. This one's for the square of a difference. So when you have a minus b squared, the only thing that changes from the last one is the sign of that middle term. It just flips to become minus 2ab. The a squared and b squared, they stay positive. Okay, this next one is my personal favorite. It's often called the difference of squares, and it is so slick. When you multiply a sum and its matching difference, like a plus b times a minus b, watch what happens. The middle terms,
a plus ab and a minus ab, just poof, they cancel each other out completely. All you're left with is a squared minus b squared. So clean, so useful.
So here they are, our 3 special moves, all lined up. Just take a second and look at the pattern. Notice how the only real difference between the first 2 is the sign of that middle 2ab term. And in the last one, it's gone entirely. Having this mental chart is a total game changer. All right, pop quiz time. Take a look at this. Someone tried to expand 5m plus 6n squared, and they got 25m squared plus 36n squared. Is that right? What do you think? Is anything missing?
Aha! If you said they forgot the middle term, you are absolutely right. This is, without a doubt, the most common mistake people make. The correct answer has to have that 2ab part. In this case, a is 5m and b is 6n. So 2 times 5m times 6n gives you 60mn. Forgetting that middle term is a classic trap, but not for you. Now you know to look for it.
Okay, let's bring it all home and talk about the new math superpower you've just picked up.
So, what are the big things to remember? First, the distributive property is your best friend for breaking down tricky multiplication problems. Second, that property leads to these powerful shortcuts called identities, and I want to master the big 3 we covered. And I'm going to say it one more time. Always, always remember that middle term. So we'll leave you with this thought. We started with a pretty simple puzzle about 23 times 27, and we ended up with this universal key for algebra. Now that you have this tool and you know how to look for these patterns, what other math problems can you go out and unlock? You're going to be surprised just how often this whole idea pops up. Happy calculating!